In this lesson of the graph for near, we're going to scaffold out our project, our subgraph project. But before we do that, we should probably define exactly what a subgraph is. So subgraph defines the data the graph is going to index from the near chain, how it's going to store it. It's made up of three main pieces: a manifest, an entities or a schema, and mappings. So in this pathway, we're going to discuss each one of those and go through them in detail one by one and understand what they are and how they work. Before we do that, though, we should also talk about contract accounts. So on near, we don't have events, at least not yet. On Ethereum, events are emitted when a contract does something, and then the graph can listen for and then act on those events. On near, the graph is actually indexing blocks and receipts, and the receipts specifically can contain logs, ideally in a Json format if the developer codes them in, so that we can get those logs and then work with the data that's provided by them. So first thing we need to do is decide on what near contract we're going to work with and identify for our subgraph to listen to. You should note that at this time, you can only listen for contracts on the near mainnet. Testnet's currently not supported, but I do understand that's in the works with the graph. So for the purpose of the rest of this pathway, we created and we deployed a contract account that we know is emitting logs in a JSON format. So we got something to work with. It's a did registry contract. So basically it allows somebody to associate their near account with a decentralized identifier, which gets stored on the chain. And then through our subgraph, we'll be able to query the chain, or query and get the data back, the decentralized identifier, and then call the relevant information that that decentralized identifier corresponds to on Ceramic Network. It'll allow us to make kind of rich things like rich directories, like a near guilds directory or a member profile directory, for instance. Just going back to events for a minute. So on Ethereum, you know that you can go to Etherscan and basically look up a contract and see all the events that it's emitting. So it makes it very easy to build a subgraph that can listen for those. Ethereum contracts also have ABIs, application binary interfaces, which basically define the methods and the structures that you can use to interact with those contracts and the shape of the data that will come back. Near contracts compile to WebAssembly, and they don't have ABIs, and they don't have Etherscan support. So, at least not yet. So basically, you either need to be the developer and know what was coded into the contract and what it's emitting, or you need to look through the source code on GitHub or whatever repo it is to figure that out. Recently, a near enhancement proposal, NEP 171, was introduced. It was primarily aimed at NFTs to provide an event emitting structure, but it's also useful for other developers to work into their contracts now as well. To get that information back. So I'm just going to give you a quick look at what that looks like. Let's create a new file here. So this is in assembly script and probably looks very similar in Rust. But basically you're outputting a log at the end of some function that gets called that you deem as important, that you want the data to come back from that. So it's just a standard JSON object. It's got an event JSON object inside and also another data object inside of that. So standard and version will pretty much stay the same unless the standard changes, of course. And then you have this event field here, remove editor. So this is basically the function that this log pertains to. And it's also the function that we'll then be able to listen to through the subgraph in order to get the data, this data here, sent back through our Graph Cli query. So in this case, we're just sending back 3, editor, time, and remove by, and each has a type. So editor is a string, it's within the quotation marks. Time is actually just a big number. U64, I believe, and remove by is another string there. So anyways, these are the types of logs that developers can work into contracts in order to make the near contract work well with the graph. And it doesn't have to be this standard, but I would suggest that you work in a JSON compatible format so that you can work with the different data and variables easily once you get it back. I'll just delete that, go from here. All right, so with that background, we can now talk about scaffolding. Almost. We have to install Graph Cli in our project because we're going to need basically 3 commands that it provides: graph codegen, graph build, and graph deploy. And we'll talk about each one of those and what they do a little bit later on. But in order to install the Graph Cli, you just go into your project, whether you're on Gitpod or have this cloned locally to your machine here, and do an npm install globally add graph protocol graph CLI. I've already done this, so I'm not going to do it again, just to save a little bit of time here. But of course, you should. And then when you're done, just type graph and let it run to confirm that you actually have it installed correctly. If you do, you'll see a welcome message like this that says, welcome to Graph CLI version 0.23.2, or whatever version it is by the time you work through this pathway. Next up, you should already have the same structure here. This is the Learn Web3 dApp. So if you look through the various files and folders here, there's one called Subgraphs, and that's where we're going to put our subgraph. So we're just going to change to that directory. Subgraph, if I can spell. There we go. And then once there, we're going to clone a branch, a template that we put together to make it easier for you to build these subgraphs. So we kind of put the structure in place. So you'll just clone this branch specifically in your graph into that folder. And again, I've done this, so I won't do it again. Let's get rid of that. And when it's done, you should have the project scaffolded out in your near subgraph folder, where you'll see 3 directories and then a few other files. Before we get to those files there, you're also going to want to make sure you're using the right version of Node, which needs to be greater than or equal to 14.17. So if you're not, just switch to that, however you have it configured on your system. And then do an npm install to install all the dependencies required for the package there. I've already done that as well too, so we'll skip that piece. All right, so at this point, you've got your project scaffolded out. The files that you're really going to be interested in the rest of this pathway are the subgraph.yaml, which is the manifest file, the schema.graphql, which is where we'll be putting the entities that we build, and inside the source folder mapping.ts, which is the logic that takes the data from the near chain and then maps it to the various fields in the entities that we'll be putting in the schema file. The other one that you're probably going to have to deal with is package.json, as we will need to change this section here to your specific information in order to deploy your subgraph to the hosted service. These other folders get auto-generated based on some graph commands we run. So graph codegen builds this generated folder and puts this code in here, and graph build generates this one with the build that will then eventually be deployed to the hosted service. We're going to cover that all in a little bit more detail later on. So that is your project scaffolded out, and we're now ready to go. And so we'll get into the subgraph manifest in the next lesson.